Welcome back. Today we will be talking about graphs of sine and cosine function. And graphs of sine and cosine function, they are related to each other in many ways. So when we are talking about the graphs of sine and cosine function, as you can see from the graph, it has a wavy curve, right? So it has a wave and it passes through the origin 0 0, and the period it is listed as 2 pi. So 2 pi is the one cycle in which the sine function will be completed. So the domain will be the whole entire number line, that means negative infinity to infinity, and range is negative 1 to 1. The reason is the sine and cosine function, they are oscillating functions. So the end behavior of the sine function, and the same as with the cosine function, is the oscillation part. So the maximum height the sine function can attain is 1, and the minimum height is negative 1. It is just like a spring. It keeps on bouncing up, down, up, down. So these are called sine waves or sine function. The real life example, as you can say, just like ocean waves, right? They keeps on in a regular fashion. I'm not talking about the high tide or low tide, but in a regular fashion. So they are a very very good example of these sine and cosine function. The same thing when in the uh, they do EKG, right? When they monitor the heartbeat of any person. So those things, they are very very practical examples of these function. So the local maxima, that means where the peak is, as you can see from the graph, the peak on the graph is at pi 2, and every time the cycle finishes and it comes back again, that is why plus 2k pi, and the minimum is at 3 pi 2. So minimum implies where there is a valley, where there is a dip, and k is nothing but the integer. So maxima is where there is a peak, minima where there is a valley. Um, so as I said, the sine function, it oscillates. It has a period of, it is a periodic function basically. The sine and cosine function, they are periodic function because they finishes one cycle in 2 pi, and but it depends on the function. That is why it is 2 pi over b. B is nothing but the coefficient of the x in the function, and sine function is symmetric to the origin. You can see from the graph, it has an origin, and so we are, whatever it is on the right hand side, it will be on the left hand side. It will be symmetric to the origin basically. If you understand the graph of a cubic function, so cubic function, it is also symmetric to the origin. So the sine function, if you can relate to the cubic with respect to the origin, it will make more sense. So you have learned about the parents graphs and the transformations in algebra 1. So taking you back there, so the parent function for sine, we can say in terms of transformation, is a times sine b times x plus or minus c, parentheses close, plus or minus d. So I just told you that the period of the sine function is 2 pi over b. So b is nothing but the coefficient of x. A is the vertical stretch or shrink. It is just like you are holding a hair tie and then you are stretching it up. When you stretch it up, the graph becomes narrow, and when you let it go, it becomes wider. So stretch will happen when it is greater than 1, and the shrink will be when it is less than 1. So b, as I said, it is a coefficient of x, and it represents horizontal stretch or shrink. But here's the thing, whatever is there with the x in the parentheses works opposite. So the stretch will be when it is less than 1, and the shrink will be when it is greater than 1, because it works in the opposite fashion. Now the another component is c. So c is added or subtracted with x. So that represents the horizontal translations to the right on the graph or to the left on the graph. This c will also help us to, the whole entire parentheses bx plus or minus c will help us to calculate few other things as well. So d is the vertical translation. That means we are creating a new x-axis, up, above the original x-axis or below the x-axis. So this parent function y is equal to a times sine bx plus minus c plus minus d is very, very important. And the same function will go with the cos. Instead of sine, we can write cos. And so you need to keep in mind the basic translations you have done in algebra 1. Now moving to the cosine function, so the same pattern. If you look at the graph of the cosine function, it does not go through 0, 0. So at the y-axis, we are looking for when x is 0, y is taking the value of 1. It has a period of 2 pi, the cosine function, and it oscillates as well, just like the sine function. So the domain will be negative infinity to infinity. Range will be negative 1 to 1. The reason is it oscillates, it bounces up and down between negative 1 to 1. So the end behavior is oscillation. And then between negative 1 and 1. After that, let's talk about the local maximum and local minimum. So as I said earlier, local max, that means the highest value. At what x it is reaching the highest, and at what x it is reaching the low. So x is reaching the highest at 2 pi, so 2k pi. So 2 pi is one cycle is run. So one cycle times any integer, that means that many cycles are done. Local minima will happen at pi, because on the unit circle at pi we are getting negative 1 and plus any other repeated cycles. So again, for understanding, max is nothing but the peak or the mountain peak, right? And the minimum is just the valley. So we have peaks and then the valleys that represents max or min. And when we are talking about max and min, we are talking about the local max and local min. And this concept will also help you in calculus, when you will learn calculus. So as I said earlier, sine and cosine, they have the same period. So 2 pi over b. B, I have already told you, b is nothing but the coefficient of x. And cosine function is symmetric to the y-axis. It has a symmetry with respect to the y. So if I have to write the parent function for cosine, it will be y is equal to cos, y is equal to a times cos, I forgot to write cos, so it is the same as the sine function. A time it should be a times cos bx plus minus c plus minus d. So please add cos after a, because I typed in, I wrote first and then I'm doing the voiceover, so I cannot rewrite it again. So but yes, it should be a times cos bx plus minus c plus minus d. Now few important things to keep in mind. The d, that is a vertical translation up and down, right? So if d is greater than 0, that implies we are creating a new x-axis above the original x-axis. So horizontal axis about y is equal to d, that means it is above the x-axis. If d is less than 0, then that means from the original x-axis we are creating another x-axis that is below. So horizontal axis y is equal to d will be below the original x-axis. Another point, very, very important, you will read some words that's called amplitude. Amplitude is nothing but the absolute value of a. So be careful whenever you write amplitude, it should be absolute value of a. So let me try to sketch a curve. So So let's have a rough graph and let's create the axis. Not that. Let's create another x-axis. There we go. So if this is the x-axis and we have a curve right here, so when we are talking about the amplitude, we are talking about the height of the graph basically, because it is a stretch, right? So how high the graph is going up. So the amplitude, that means it can be more defined as height from the center to center line to the peak. Further, we can also say about the amplitude that because it is the height, that means to the max or to the min, right? Peak and valley. So amplitude can also be calculated that 1/2 maxima minus min. So if I know the height of max, that means the peak from the center line to the peak or center line to the valley. If I subtract them times 1/2, that will be the amplitude. So basically, vertical height from the midline. That is why we use we use the word midline when we are talking about D, when we said y is equal to D, right? That is also called the midline, because we are creating a new midline because there is a vertical translation up or down. Another point, if we have to calculate the left and the right endpoints, of one cycle, interval, then we can use bx plus or minus c. That means what is inside the bracket after a. So bx minus c is equal to 0, or bx plus or minus c equal to 2 pi. Now this process is also called phase shift. So in many textbooks they will say bx minus c is equal to 0, bx minus c is equal to 2 pi. In other textbooks they will say x is equal to c divided by b, because if you solve bx minus c is equal to 0, you will get x, value of x is equal to c divided by b. So let's create a coordinate plane. Let's say this is the original curve and we have another curve right here. So when we are talking about the phase shift, they are talking about what is the distance between the two curves. That is called a phase shift. So be careful with these words. So basically they are saying how far the function is shifted horizontally, right? Because there is a shift from the usual position. Right? So all these key points are very, very important when you are analyzing the sine and the cosine function. Now, if I have to say period, as I said earlier as well, period for sine and cosine function is always 2 pi divided by the coefficient of x, and the coefficient of x is nothing but b. So going back to the function again, y is equal to a, and again I forgot to write cos or sine. Please write cos or sine. So b is what I am looking for. Okay, let's go and understand the intercepts now. So this is the graph of the sine and the cosine function, and you can see here in the sine function we are getting the intercepts. The first intercept will be at 0 and 0, and 0 and 0 will be the intercept for y as well. But for cosine we are getting the 2x intercept and 1 y intercept. Now, to get the points, how to graph the sine and cosine function, what we can do, what we did in algebra 1, create x and y table. And using that x and y table, you can refer back to the unit circle to graph it. Let's take one example and we will discuss what key components you need to keep in mind while analyzing the function. So y is equal to 2 sine 4 times x minus 2 plus 3. So let's analyze it. So the first analysis will be about the amplitude. Remember, amplitude is the absolute value of a. What is a in this case? It is 2. Second point, period. How to calculate period? The sine and cosine, they have a period of 2 pi over b. What is b in this case? B is 4. So that will be pi over 2. Then phase shift, what we just did. So phase shift is nothing but your bx minus c is equal to 0. And that will be 0.5 to the right, because it is negative 1/2, that means it will be positive 1/2, because whatever goes with the x-axis, it is opposite. So bx minus is equal to 0. So that will be x1 negative 1/2 is equal to 0, x is 0.5. So we did amplitude, we did period, we did phase shift. Now midline. Midline, that means what is the vertical translation up and down. So remember, I just told you that midline we are talking about d. What is d in this case? D is 3. So the new axis, x-axis, will be at y is equal to 3. That is called new x-axis. So if you analyze it in these 4 steps, and after this you can create x and y table and graph it, but analyzing the sine and cosine function with these 4 steps, it is very, very useful, and the chances of error will reduce. So write it in the bullet points or label it properly. The parent function will be again f of x. Again, I forgot to write cos or sine. Please include that. a times sine or cos bx minus c plus d. And I will see you in the next video. Bye bye.